So we are starting with the ideal gas equation. First, we have to see where it comes from. It's a combination of Boyle's law, Charles' law, and Avogadro's law. Boyle has volume inversely proportional to pressure. Charles has volume proportional to temperature, and Avogadro has volume proportional to the number of moles. And on this side, I've noted the things that have been kept constant. 4 variables, you can play with 2 have to be constant. If we take these 3 proportionalities, the lowercase alpha means is proportional to, and we combine them, we can say that volume is proportional to the temperature times the number of moles over pressure. Well, a proportionality doesn't do you much good, but there's this cute thing we can do is we can stick in a constant. And when we put this constant in, we can say V equals RT over N, RTN over P, or rewriting it, we can say PV equals nRT, where PV equals nRT is in fact the ideal gas equation. So pressure times volume equals the number of moles times this thing called R, which is the gas constant, times temperature in Kelvin. This describes an ideal gas, and we deal with real gases. But a real gas, something like oxygen or nitrogen, approximates an ideal gas at high temperature and low pressure. Believe it or not, high temperature and low pressure are room temperature conditions. What we'd have in the lab, 25 degrees C and 1 atmosphere. That's atmosphere over there. It's kind of hard to tell. But that's when a real gas most resembles an ideal gas, high T and low P. And remember, those high temperatures and low pressures are relative. But it's what we find on the face of the planet. Okay, so before we can work with this, we need to evaluate the gas constant. Which means we just have to figure out what it's equal to. And to do that, we're going to work at STP. We talked about this before. STP is standard temperature and pressure, which is 1 atmosphere and 273 Kelvin, or 0 degrees C. 0 degrees, did you forget that? 0 degrees Celsius. It just so happens that 1 mole of any gas at STP has a volume of 22.4 liters. This number is a good number to know. It can sometimes lead you on some nice little shortcuts, and this is called the standard molar volume. Standard because it's at standard temperature and pressure, molar because it's for 1 mole of a gas, and volume because it is in fact a volume. It's liters. So 1 mole of any gas at standard temperature and pressure will have a volume of 22.4 liters. So if we want to evaluate R, we're going to isolate R, put it on one side of the equation. To do that, I have PV. I'm going to divide by N and then divide by T to get them on the left-hand side of the equation, equals R. And we know all these values at STP. We know that the pressure is going to be 1 atmosphere. The volume will be 22.4 liters. N is 1 mole. And the temperature is 273 kelvins. So if we do a little multiplying and dividing, you come up with the value for the gas constant of being 0.0821. The book may say 0.08205, but you don't have to do that. And the units are liters times atmospheres divided by moles Kelvin. Now, while I am fond of the combined gas law, P1 over T1 equals P2 V2 over T2, Sir Dr. Roger Lewis says this is his favorite because you can get literally every other gas law from it. That's the one he remembers. I remember the combined gas law. Take your pick. You need to know them both. They're both extremely handy. So put this in your box of equations, and we'll come back on another video and do a couple of problems.